This is the second half of the RNA transcription and translation notes. You should already have this note page, so don't go up to the drawer and get anything. You just need to open your notes up to this section. It should be the section you haven't completed. So we've already done RNA and transcription. You should feel good about both of these before moving on to this. If you don't feel good about transcription, stop, go back, do that again before you move on. It's going to get more confusing if you move ahead before you feel comfortable in transcription. If you feel good, let's keep going. We're going to do translation now. So remember, we've made the RNA. That was transcription. We took DNA and we made RNA. And now the RNA has been transported out from the nucleus into the cytoplasm. We're specifically making messenger RNA because, see, it's coding for the messages. So we're making mRNA. Now, this messenger RNA is not the end goal. This is not what we wanted to make. Remember, we wanted to make a protein. So we haven't made our goal yet. So we're not done. Transcription's just one part. We're moving the message. But now that RNA needs to connect to a ribosome. Remember, what does a ribosome do for us? What is the function of a ribosome? Do you remember? It said it in the notes earlier too. We need to remember these things. Ribosomes make protein, and our RNA is trying to help us make protein. So the function of a ribosome is to make protein. So the RNA is going to go out there and help us make protein. So we made messenger RNA, and we're going to go out to the ribosome. If you remember, the ribosome has ribosomal RNA, and we're going to kind of connect to these things to end up building protein. Remember, I said it already once in these notes, but I'll say it again. What does protein do for us? Protein is our blood, our structure, our immunity, our muscles, our enzymes. Protein is so much of the things we are and the things we need that it's extremely important to be making protein, and not just sometimes, but all the time. And not just okay protein, but good protein. Good protein that our body can use to do the things we need. Imagine if your blood was made badly. You don't really want blood that's bad, right? How would you carry oxygen? How would you do all the things you need to do? We need good blood, so we need good proteins, which means we got to start here. We need to have good DNA that made good RNA, and now we're going to make protein. So all of the proteins, they function because DNA holds the information to make them. Your DNA tells your body how to make your proteins. And that's why our proteins look different. Think about our hair color and our hair style. Some people are straight, some people are wavy, curly. Our DNA tells our body what type of protein to make different hair colors and different hairstyles. So this is held down in our DNA. And that's why sometimes you match your parents with your hair style or your hair color, because your DNA came from them. We're going to use our DNA to make our proteins. I'm going to flip the page with you. We're on the back page now. And this back page is full of information, so make sure you're paying attention. So remember, we're going from DNA to RNA to protein. We did DNA to RNA already. That was transcription. We made the RNA message so that we could take it outside of the nucleus and get it to the ribosome. And that's going to make protein for our body. The next process is taking RNA and making a protein, and it is called translation. We call it translation because think about it. When you translate something, you change languages. Well, we are changing languages here. We're going from nucleic acid to protein. We went to a different macromolecule. So we translated it. We're literally changing the chemical language of the information to change what it's doing. So with translation, we're going to need the RNA and we're going to need ribosomes. We're also going to need the monomers of a protein. Do you remember what the monomer of a protein is? The small part of a protein? If you don't remember, I want you to pause the notes and I want you to go find it. In the book, in chapter 2, you can find it in your macromolecule notes, also chapter 2. You can go back onto Canvas real quick and pop up the video on these notes. It's down there under all the old notes. What is that monomer? Go find that. Okay, the monomer of protein is amino acids. I hope you already knew that, but if not, I really hope you went and looked it up. You're not going to remember anything unless you take some ownership and look things up. So protein is the polymer, the big part. The monomer is amino acids. Here are our steps of translation. We're going to go through the steps, and then I'm going to show you how to do this. So the first step is the RNA goes to the ribosome. We don't really show this step. It's just important to know that it's happening. The ribosome reads the RNA 3 bases at a time, 3 letters at a time. These 3 bases are called a codon. I would star number 2 because there's a definition in there that's new for us, the word codon. A codon is just 3 letters that we're going to use to read an amino acid. So codons are 3 letters. Each codon, each group of 3 letters, calls for a specific amino acid. There's more than one type. There's quite a few types, as you're going to see. These amino acids will build to make the protein. The ribosome is going to stop reading when there are no more codons. Remember, if a codon is a group of 3, then that means the ribosome will read groups of 3 RNA letters until it stops having groups of 3. When that's done, then it's going to stop coding for a protein. Now, how do we find amino acids and how do we read these codons? Couple things we need to do. First off, I want you to see what this kind of looks like. Do you see how there's groups of 3 letters? These codons read for us the different amino acids. You do not have to draw this. This is not what yours is going to look like, but I kind of want you to see what it really looks like in the real world. How do we read the codons? If I have this piece of RNA, I start just like I read a book. I start from the left, and I make groups of 3. So I pulled out AUG. That was a group of 3. Then CGU was a group of 3. ACC was a group of 3. GA, do you see how that was not a group of 3? That is not a codon. I can't read it off the codon chart, which I'm going to show you in a minute. I can't do anything with it. They get left alone. For this protein, I would have 1, 2, 3 amino acids, and I would read them off of the chart that I'm about to show you. There's nothing I can do with just a G and an A. I need a codon. Now at this part, you see the amino acid is found on the codon wheel. Well, what's a codon wheel? Pause the video, go up to the chapter 13-14 drawer, and go grab the codon wheel and the codon chart. It's 1 page, 2 big pictures on it. One looks like a wheel, so you'll be decently easy to find. Go get that, and then I will show you how to read both of them. Okay, on the wheel is read from the inside to the outside. So the biggest letters are in the inside. You see that? The first set of 4 there are big letters. That's the first letter in the codon. So for this codon, A is our first letter. So in your big center of the wheel, you're going to look at the A. Now from that A, you're stuck in the A section of the wheel. We're going to move out to the second row. See how within the A section, there's another GCAU in the second row out? That's for the second letter. So now I'll go from that A, the big A, to the second U. So now I've got the AU. And then you see under the U, there's a third, even smaller section that says GCAU again. We're going to go from the A to the U to the G, and that gets us to methionine. All of these names are super weird. You will never have to pronounce them. You will never have to spell them without looking at them. With them on this chart, I do expect that you to always spell them correctly. If you didn't see how to do that, let's look at this second one. So I have UUG. I go to the biggest U in the middle. Now I'm stuck in the U box. I go to the second layer out to another U, and then to the third layer to the G. Follow that U, U, G, and I get to leucine. So that's how the wheel is used. If you don't like the wheel, you can also use the chart below it. The chart below it is a little more confusing. But if you look around the sides, it tells you the first base, the second base, the third base. So what you do is you match them all up. So you go to the first space, and it would be an A. So find A on the first base row. Then find U on the second base row. And I actually use my fingers. I put a finger on A, I put a finger on U, and then I pull them together and connect them to whatever box I'm in. Then go to the third row and find the G. And that should have still taken you to methionine. Same thing with UUG. Find the U in the first base row, the U in the second base row. Pull your fingers together to find them in the middle, and then find the G in that small section. It should be leucine. You're going to get really good at using this. Trust me. It takes a little bit of practice, but you're going to get really good at it. Here's our first practice on the notes. Let's go ahead and do this. Please check with me if you don't feel good about this. Don't just stop and move on, but actually look. So first thing you're going to do is label your codons, pull them out of here, and then pull your amino acids off the wheel. I'm not going to talk about this yet because I want you to try and do this. Okay, if you're not ready, pause the video and keep working. But first, our codons. A, U, G should be your first codon, right? Pull the 3, bring them down. C, G, C should be your second one. U, U, A should be your third one. And C, G, C should be your fourth one. Now on here, AUG, I'm only going to do this first amino acid with you. AUG, you should have been able to follow, and I believe that should be methionine. I actually don't have a wheel in front of me right now, so I don't even know these without the wheel, which should tell you that I will never make you know them without the wheel either. I only know most of these if I have the wheel or the chart in front of me. You will always have the wheel or the chart. For all of your practice, for your mini EOC for me, and for the real EOC, you will always have some sort of chart. So I've given you the first amino acid. You should have got the other 3. If you want to double check, call me over. Let's check it. This is your practice on your notes, and this is the only practice on your notes. Just like translation, transcription, replication, all of them, we're going to do a practice on this now. So you're going to want to make sure that you feel really comfortable and confident in this practice and that you feel like you know how to use the wheel and the chart. Make sure you can use both because I can't promise you which one you get on assignment. I don't get to pick which chart I give you on the EOC. They will put one on there. So I want you to feel good about both of them. So go ahead if you need to and re-listen to this part of the notes. Read through your notes or ask me to help you with anything. But this right here is all I expect of you when you do translation. This little set here, not a picture like we did with transcription and DNA replication. Okay, if you're ready, you can go ahead and move on to your next assignment.